So our next speaker is Tom Schenk from the City of Chicago. So Tom is a researcher and author in a number of fields, including data science, open data, data visualization, and education research and policy. He is currently the Chief Data Officer at the City of Chicago, which includes leadership of the strategic use of data to improve the efficiency of city operations and improve the quality of life for residents. Tom has led the expansion of Chicago's open data portal, implementation of predictive analytics to optimize city services, and leading the city's database and business intelligence teams. Tom has also co-founded and is currently the chair of the Civic Analytics Network, an association of nearly 24 city CDOs based at Harvard University's Ash Center for Democratic Governance and Innovation. Please join me in welcoming Tom.
Good morning, everybody. I'm going to go through a couple of stories about how we use data in the city of Chicago. And I want to talk about specifically around open science. I do think Chicago is the only city, certainly the only city, and I think one of the only government entities unto itself at state and local governments that has an idea around open science and how we can leverage open science to improve where we live. And I'm going to build out a story, first talking about open data, which is a mainstay around governments today. But how can we extend beyond just open data, and how can we, again, leverage open science within a city context, within a government context? So first off, people are very important to us when it comes to technology, when it comes to data. In our vision, on Chicago's technology plan, that we believe that the power of technology is driven by the people who benefit from it. That's the purpose. That's what we always need to be thinking about. Not just open data for the sake of openness, but thinking about how people can use that. Now, you've heard from different actors, from nonprofits, from those that speak more at the federal level. So we're going to ground base on what city data means. And we're going to do a little bit of a quiz. Can anybody spot the pothole in the picture? All right. We're going to get a little bit tougher. Can anybody spot the potholes in the picture? All right, that's Long Hall set. Steve, that's your picture, in fact. There you go. So Creative Commons, very useful in assembling slides. So we published data on the open data portal. In fact, just a couple weeks ago, I've not even updated my slides yet with the more recent design, but we just redesigned and relaunched our open data portal. Our portal's been around since 2009. We've really accelerated the growth of that portal in 2011 with the current administration, with Mayor Rahm Emanuel, who appointed the first chief data officer ever at a city. And I'm actually the second chief data officer for the city of Chicago. And this is all the potholes reported on the city. So what we saw earlier was we can go to a street here and we can take a look at what a pothole might look like. We can go to Halstead, where that picture was taken, or maybe it was Milwaukee, and look at all the potholes. Or we can take a look across the 235 square miles in the city of Chicago and look where all of those potholes are. We have a lot of data on the data portal. This is actually a data set of the red light camera tickets issued by the city of Chicago. We have other things such as speed camera violations, a list of problem landlords that have repeatedly had serious violations with the city of Chicago. We publish a list of that. Public chauffeurs, people who are allowed to drive cabs in the city of Chicago. And even recently, we published every single cab trip in the city of Chicago. Now, some of this data is quite robust. Potholes, I think there's about 600,000 potholes on the data portal. Taxi trips, there are 108 million taxi trips. We have every single crime in the city of Chicago from 2001 to present, which is about 6 million rows. But do you know what the most popular data set on our data portal is? It's 33,000 rows. The names and lists of city employees and their salaries. So again, it goes back, the power comes from those who benefit from it. It's not size, it's not kind of sexiness of the data set, it's what people derive from it. And looking at people's salary, people derive from. And this all comes from an executive order that was signed in 2012 with Mayor Rahm Emanuel, the Open Data Executive Order, which empowers that there will be a data portal. And there will be a website, data.cityofchicago.org, where our data portal is located at, where we'll upload this information, and it will be maintained. And we have this in our tech plan. that we're going to leverage data and new technology to make government more efficient, effective, and open. Now that's more than just we're going to release data on a data portal. We didn't have a mission in our tech plan saying we're going to release data on a data portal. No, we're going to use data to make government more efficient and effective. And that's going to take place in a number of different ways, one of which is open data. Open data is a strategy, is a means to the ends that we want to get to. Now we talk about that we're going to increase and improve city data. We're going to increase the quality and make it available. Again, but this is in the context of a slightly different mission, not openness into itself, not transparency into itself, but for a more effective and smart city. Now, one thing open data does, obviously it makes data publicly available, that's within its name, but it actually is a great job at providing a means to create an ecosystem around data, which includes multiple stakeholders and initiatives that extend beyond transparency. It's not just about transparency, but it allows a community to be formed. Scientists can use the data portal. Well, let me do a poll here, right here at the University of Chicago. Who has seen the city's open data portal before? Okay, about half-ish, right? So those who've come to it, and so we've come together and we can now have a conversation. We can actually talk about this thing, the data portal. We can talk about the data there. We can talk about how you've used that data. That's part of becoming a community. It's not this extract conversation of like, oh, do you guys have that data, or how do you use that data? You can actually have access to that information. You can use it for your own benefit, to whatever means that you need. If it's towards an academic paper, if it's towards research, if it's towards a class where students can use that in the class, or it could be a community organization using that data, trying to understand crime in their community or where needs are throughout their neighborhoods. So we can use this information, we can use that data as a community. And we see a community come together. Right there in the background, the faded background is meetups. This is actually a 1-year anniversary of Shy Hack Night. At this time it was called Open Gov Hack Night, where folks have come together. This is a room of about 20 or so folks. Steve, I'm not sure if you were in that particular meeting. Were you? Yeah. So you had 20 folks. Now it's a much larger organization, right? Where, again, people come together on a weekly basis and meet and discuss about data. Some of it's how can we use the city's open data. Some of it's talking about community issues and thinking about how they can use data to do that. And it's recognized. National League of Cities pointed out Chicago about partnerships and how we leverage open data to help seed a community. Whether it's the community, whether it's researchers, whether it's companies that we can work with and think about how they can use that data as part of their startup. Spot Hero, the app that you can use to reserve a parking spot and get a discounted rate on that, started out of a hackathon that was using Chicago data. Spot Hero uses no Chicago data. But those folks, the founders of that company, came to a hackathon, were thinking about certain ideas, trying to use the data portal, and there was a seed for an idea for now a lucrative company that has spread across to a dozen cities across the United States, and is one of the most popular, most valuable startups in the city of Chicago within the startup community. So that meetup I showed you, that little meetup that had 20 or so folks for that first anniversary, this is what a meetup looks like now. Between 80 to 150 people show up on a weekly basis. Right? That's a robust group, and that's over the course of now 5 years. They just had their 5-year 5th birthday from that 1-year birthday. And there's even more than just that. There's a lot of meetups, but you have Shy Hack Night, which meets every Tuesday, and there's the City Data User Group, which is a little bit different of a focus. That meets the first Wednesday of every single month. So now you're starting to have this community come together because of the open data portal. And of course, you have apps. People love apps. This is a website called sweeparound.us, Sweep Around Us. This is a website that was created by a guy who actually worked at a startup that sold to Google for about $39 million, Songza. And now Google Music uses their technology. But this is a good programmer, Scott Robin, right? This is not somebody that didn't have anything else to do. He certainly had a job. He was very busy, has a couple kids, and he still maintains this website. But this is a free website that you can go to that uses the open data portal. It shows you where the streets are going to be swept. And you can sign up for email alerts, text message alerts. You can put it on a calendar so you know when you can move your car instead of just looking at those orange signs. Now, the city of Chicago, we could build this website, but there's a very important quality in any sort of IT worker that works for the city. You can't design a website well. It's a very important job criteria. And so when other folks come along like this, they can create websites that work, that are very functional. And there's a very serious conversation about how a lot of times, in more seriousness, we have to program for every potential use case that might exist. And a lot of times that leads to a website that's very confusing and very complex because we're trying to program for a lot. This can really answer the simple questions, the useful questions for everybody. There's other websites such as Large Lots, largelots.org. There's a great story behind this. It's, for those who live in the Hyde Park area and those who live in Chicago, might know that there's vacant lots that are sold for $1 by the city of Chicago. Lots are owned by the city of Chicago for $1. We open up some of those to be sold for $1. When the city of Chicago first rolled out this program, the application process was complicated. It involved mailing forms. It involved a lot of different things that did not work out very well. And you had a local startup here that said, you know what, you have a lot of data on the data portal. That's part of the application process, right? You need to make sure that the property is in a community and all this stuff. So they leveraged the data from the data portal, combined it with some online forms, and they're able to make an electronic process. And the city of Chicago actually adopted that process as the formal process. This is the way that you now apply. Before you went to a government website that said, okay, you got to mail this in, you got to mail that in, you got to certify this, you got to certify that. That was complicated. We looked at this process, said that's better, partnered with a nonprofit and that startup, and we now have a better process because, again, that community that starts and comes out of open data. ChicagoFluShots.org, a simple website, but an important one for a couple of reasons. This just simply shows you where you can get flu shots throughout the city of Chicago. This is a data set on the data portal that somebody created a very nice app. This app itself is an open source app. The code behind it is open source. In fact, the person who created this application works here at the University of Chicago out of the IT services office. He's long been a programmer here, Tom Campari. And he created this app, and it was an open source app, and other cities liked this. They said, well, that's simple. This is a simple approach. The data set's pretty simple. Other cities would publish it as well. But they didn't have a great app to do it. So other cities actually adopted the app itself. Boston took the source code of this app, used it, and also has bostonflushots.org or something like that. So now expanded beyond just open data and these services that are nice, these apps are nice for people who live in Chicago, and now it's expanded that ideas and the apps themselves are now spreading across the cities. We're now sharing ideas. That's an important step for an effective government. An efficient government, because it allows us to take ideas from others who've created good ideas and use it for ourselves. And of course, with our partnerships, academia is a key partner. These are some of the academic, we've worked with Northwestern University, DePaul, certainly University of Chicago, in a lot of different ways we've worked with them. And one of the most important projects that we've been working on is the Array of Things project. Now, the Array of Things is going to be a set of nodes, all of them that have sensors, about 500 of them throughout the city of Chicago. They're being developed here at the University of Chicago at the Computation Institute and Argonne Labs. And we're going to hang these around the city of Chicago. And it's going to measure different things, such as sound and vibration, low-resolution infrared cameras, so we can tell, is the ground icy? It's going to have climate, environmental data. We're going to be able to measure these things on a block-by-block basis. I mean, even a simple thing like weather. What's the weather right now? A lot of times you're relying on temperature sensors that are placed at the airports, which is some of the worst place to actually consider saying, okay, this is representative of what it's like. And let alone, even if in a neighborhood such as Hyde Park versus the downtown area, the amount of concrete in the downtown area and the urban heat island effect that occurs by the concrete absorbing that heat all day and then releasing that heat all day. You get a different temperature, you get a different climate. Against the lake, far away from the lake, from snowing to mild. I think last week it was 50s here in the city, but you got to the outer rims, it was 70. Right? It's just that dynamics of the climate. So if we can now understand this on a block-by-block basis, we can now think about things differently, such as pollution, such as climate, such as weather. The design of these, in fact, are open source themselves. You can 3D print the casing for the Array of Things. The schematics, the programming code, all of that is available online. So it can be adopted by other cities. And in fact, there's a couple dozen cities that are going to adopt this. And the data itself is going to be available on the Open Data Portal. So you're going to be able to get to it. It's not just for the scientists. It's not just for people who work in government that are going to be able to have access to this. But it's going to be for the public. So if you're a school teacher in 8th grade or in high school and you're trying to introduce the concept of humidity to students, you're going to be able to look at humidity within your area, within your neighborhood, and compare that to downtown or compare that next to the beach. It's going to be available to you so you can understand what the pollutants are, what the fine particulates are in your neighborhood. What is that level of pollution? So these are some of the things that helps build that community, that partnerships, that help build new projects. And a project like this can't exist without first, hey, we have a place that we can make data available for others. And we can think about how to wrap that around. So let's go talk about city data again. So we know what it looks like on a case-by-case basis. We saw a data set, what it looks like on basically a spreadsheet on the web and what that looks like. But what about this case again? 235 square miles is the city of Chicago. How do we look at things across such a large expanse? How do we look at where the potholes are? What if I want to look where the potholes are there, or there, or there? How do I do that? So City of Chicago, in thinking about this, we launched a project called OpenGrid. OpenGrid, you can go to this website, opengrid.io. This is actually a version that you have access to. This is an open source program. And we use this program, we built this program to be able to understand what's happening across the city. We have an internal version of this that's chock full of lots and lots of data. And we have a public version here, opengrid.io, which you have access to that is powered by the data that's on the Open Data Portal. Again, building on top of our past work. And this is what the website looks like. This is searching for a bunch of data. We're looking at a bunch of data here. Sanitation code complaints. I can pull this up. This is all the different data that we're pulling up onto that map. And you can look at it. You can explore it interactively. You can filter down and say, well, I just want to look at where the potholes have been actually patched, and I can look at that in a grid view. I can export that data, so I can play around with that with myself. But primarily, I'm going to be able to look at that in a map view, such as a heat map or something else like that. So you can interact with data. You can see that data in a more effective way. Go into a data portal and say, well, here's this data, here's that data, but if I want to see these two things together, I need to pull it down and then combine it. Well, as soon as we require people to kind of download that data and mash it together, people are not going to use it, open data. You know, it's arguable to say that that's not open data, that it's not usable for the public. It's accessible, sure, for if you have the digital literacy and the technical skill to do that. But this is a website that's trying to address that challenge. This project bore out not because of transparency, not because of openness. This project bore out because the city of Chicago was hosting the NATO summit and the G8 summit within the first 8 months of the new administration starting. So you had defense ministers and finance ministers that were going to convene on Chicago. Everybody's favorite person, right, was going to be here. And the chief of staff asked, why do we have to go to all these departments to understand what's happening? I need to know what's happening right now. I can't go to this commissioner and that commissioner and ask them to turn over reports back to us. So we combined that data, and this first started as an internal project, internal only, using sensitive data and non-sensitive data. And then after using that program for a while and understanding how it could be used, we said, you know, this is actually useful for the public as well. The public has that same challenge. Yes, I have the open data portal. I go to that data set. I go to that data set. But I don't want to have to go to those individual data sets. I just want to know what's happening around us. So we built this both as an open source project, so you can go grab the code, as a frontward-facing project, so you could go run this yourselves. And then we also use that same source code on our internal project as well. So any contributions, any modifications that we make available to the public is also available to us. And vice versa, when we make an improvement for us, we can also make that available to the public. So now we're starting to have a permeable wall between a public project and a private project. And now we can start blending the two a bit more. But that's just information, right? So we have data that's made available. You can grab some information, but how do we really transform this to action? That's the final step, taking this into action. So in advanced analytics, I really think about it in 3 different fashions. One is predictions, using predictions to predict where we need to allocate our resources. Evaluate, see whether or not something we did actually was effective, and then also optimize. Okay, we might be doing a process, we might predict a process, but how can we further optimize? How could we maybe optimize the route from one person to go from one spot to another spot? How do we optimize which trees to trim first and which trees to trim last? So let me give you an example of food inspections. This is a food inspector. This is an involved process, right? You have to go through, you have to inspect. There's flashlights involved. You measure temperature of things. We have 32 of those inspectors across the city of Chicago and 16,000 restaurants to inspect, right? Look at that process. That's an involved process. That's not I'm in, I'm out, everything looks good. So how do we allocate those 32 inspectors across 16,000 restaurants? And again, 235 square miles. So it's a geographic challenge as well. Think about this is just a couple of neighborhoods in Chicago. Imagine picking out which restaurant is the risky one and which restaurant is not the risky one, and where do we send people to? What's very interesting about this project, we wanted to predict where to send the food inspectors, but we only used open data for this project. Not because we had to. We could have used internal data, we could have grabbed it from our databases and not, but we used open data, and I'll tell you the reason why after I show you what we were able to do. But we already had food inspections on the open data portal. Here's all the food inspections right here. Here's a dashboard of that. All the inspections, the risk levels, failures, the results, all that stuff. All that data was on the data portal, let alone everything else, such as crimes, such as sanitation code complaints, such as rodent complaints, business licenses, all of this available on the data portal. And so we did what data scientists do. We did some data mining. We tried to identify the predictors, and we came up with these predictors. Restaurants with previous critical or serious violations. People who have had problems in the past tend to have problems in the future. The average high temperature, 3 days going into the inspection. The risk level, which is this kind of internal categorization. The location of the restaurant, nearby garbage and sanitation complaints, nearby burglaries, whether or not the establishment has an alcohol license, length of time since the city last visited you, and the length of time that the restaurant was open. We're able to use this to predict which restaurant was the riskiest. Now, it's one thing for us to create a model and say, okay, this looks great, right? This looks great. But we actually want to go the extra step of, okay, what is the exact effectiveness of this prediction? So we conducted an experiment, a double-blind A/B experiment. I used to design cancer studies. It was one of my jobs in the past. So we used some of those same techniques that you use in a medical-style study, right, to see if something works. So we did this. We took the predictions. We made a prediction at the beginning of a month. And we put the predictions basically in a safe, saying this is what we predict over the next 2 months. And we allowed the Department of Public Health to do their work as normal for 2 months. And then at the end of the 2 months, we compared. How was our work versus what was the work that they've actually done, and try to compare the efficiency of that. And we broke it out in a couple of different ways. First, this graph here shows the data-driven approach versus the status quo approach. Now, over a 2-month period, you would anticipate that half of the violations would have been found in the first month, half the violations found in the second month, if it was truly random, right, base case. Well, the inspection manager doesn't do things at random. She's applying her knowledge. She knows, she's very experienced, so she knows where the problems are. So she's doing things not at random. She's being very targeted. And so she's finding about 55% of her violations in that first month. So a little bit better than average, or random, I should say. The data-driven model, though, would have found 69% of those critical violations in the first month. That's a 25% increase in the rate of efficiency to find that. And so what does this mean? Or if I can visit a restaurant earlier, sooner, what does that mean? Well, it's 7 days earlier. Over that 8-week period, we're able to shave a week off the time it takes to find a critical violation. And that's important. It's important because halfway through the experiment, I got food poisoning. Right? And as I'm sitting there with an IV in my arm, thinking, I should have checked the list. But as I earlier indicated, it was in a safe. There's a lot of things that somebody has to encounter with that. And again, more seriously, the mayor has recently pushed through legislation requiring that employers give employees sick time who work in the city of Chicago. That's a big policy. You know, that's something that's needed, people being able to take sick time. And that's a pretty big push to make. But what are other ways that we can make it more simple? What can the city of Chicago do to reduce the chance of somebody getting sick in the first place, such as food poisoning? Right? When you require somebody to give somebody sick time, there's a certain liability that you're taking on at that point. Certainly you are. But what are other pragmatic ways that we can reduce chances of people getting sick? And this is one of those ways. About 6 million people a year get sick from food poisoning. And that's probably underreported. That is absolutely an underreported number because it's very hard to trace down. Many people just don't report food poisoning. They think it's something else, or they just wait it out. I want to show you a slightly different look at this as well. This shows the path of the work over that 2-month period. So there was over 1,200 inspections done in a 2-month period. And over that period of time, you find all the critical violations that you're going to find. You're going to find all the violations that you're going to find. This red line shows the number, or essentially the proportion of critical violations that were found over that 2-month period. The blue line shows what the data-driven model would have done. And from about day 1 all the way through, the data-driven model was finding earlier. So this gap, this sort of relative distance, that gap, represents getting ahead of the problem. It represents reducing the chance of somebody else getting sick. This sort of technical graph turns into something very pragmatic. So how does this relate to open science? Well, a few different steps. One, publicizing and talking about the work, right? So if you can go to this website here and you can find more details about the study. You can find the results that I just showed here. And I should mention that we use this model every single day now. This is an example of the app that the food inspection manager looks at in the morning. All restaurants in the city of Chicago gets updated from the data portal, signs a prediction, and makes it available. She can sort through it. She can look for particular restaurants. She can look at the highest rank versus the lowest rank. The analytical code itself is open source as well. You can go to our GitHub website and you can actually download the statistical model that we created. Now, why do we do that? One, we could, because it was using open data, right? So we could write scripts that write programs that reach out to the data portal, bring that data in, create the predictions, and so other people could see that. So you simply could. But why? Why would we want to do that? Well, one, we wanted to share with others what the work was. So we have a technical documentation that you can take a look at. And this tells you about what we've done. So you can see the logic behind our code. You can see what the city of Chicago exactly did, the factors that matter, how much did they matter. So it accompanies something like a white paper here. But the white paper is actually completely reproducible in itself. I'm not sure if anybody's ever worked with reproducible research platforms like this, where all this text is the text that ended up in the paper I showed you just a moment ago. And then there's actually snippets of code that reach out and calculate things on the fly. So when I say that there's a 25% increase in the efficiency, what does that mean? What were my assumptions in calculating that proportion? In all earnestness, I've calculated proportions of here's the efficiency, and 6 months later, I couldn't remember how I got to that number. I can't get back to that number, right? So this helps ensure that sort of accountability for us as well. You said you did 25% increase. How? Why? What was your assumptions? And now other people can see that. And it's an important part where open science includes open data, open source, and that engagement, because we need that engagement. I don't have a dedicated slide to it, but how engagement matters is other cities can adopt this code as well. People can challenge us and try to do a better job. Since we released that open source food inspection model, Montgomery County, Maryland, a suburb right out of DC, Raleigh, North Carolina, Syracuse, New York, Denver, Colorado, have all adopted that food inspection model for themselves. They were able to freely adopt it. And even since then, too, we've challenged others. We challenge those folks that come to Hack Nights, those who come to those sort of meetings, say, can you do a better job than us? If you can do a better job than us, and you submit that code, you create a pull request, the city of Chicago will use your code to drive operations in the city. We have a very clean experiment. It's easy to demonstrate to us whether or not your model is better or worse. We have a very clean experiment. All that data is available online, so you can replicate that. The code is there, so you can see exactly what sort of model it was. And since then, we've had people try to do a better job. One, it's a very tempting thing. I know I'm kind of trolling folks when I say, can you do a better job than your government? Everybody's like, yeah, I can do a better job. And a lot of people haven't been able to. But it's also an earnestness as well. All those folks, 80 to 150 people showing up to a meeting, that's a lot of hours. I always think in terms, I'm a manager, so I always think in terms of number of hours being sat here right now, right? So if somebody meets once a week for 2 to 3 hours at a time, how many hours is that? 150 people doing that. How many hours is that? How many people could potentially work on a project? Beat us, do a better job, improve our work. How can we capture that? How can we harness that? That's where engagement comes in. I don't have slides on it yet because we're finishing out the pilot and we have a bit more work, but we've been able to build on that even more. And Steve knows about this. Steve we'll be talking later, has been a longtime member of the Chicago Hack Night community or the civic technology community. But last year we just ran a project where there was people very interested in E. coli levels in Chicago's beaches. And the model that was used to predict E. coli's level in Chicago's beaches doesn't perform terribly well. It's developed by the USGS. And it's a very difficult problem. You have a beach, very interesting dynamics, right? Just mini dynamics. Very, 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 very difficult problem. I said, this doesn't really do a good job. When the beaches, now not very often are the beaches actually have high E. coli levels. It doesn't happen that often. But when it does happen, the statistical model is only right 1% of the time, right? So that's not very good. That's exposing people to risk. Again, it goes back to sort of, can we find pragmatic ways of not having people sick? Well, our team didn't have enough time to work on it. So we released data on the data portal, and we challenged others. Say, can you do a better job? We'll provide as much context as we can around this problem. But can you do a better job? Can you predict something? And if you can, and you can do a better job than the USGS model, we'll use your model. And based off of that, they did. They did do a better job. And there's a long story there, a little bit more than I have time for today. But that's all I have today for my prepared remarks about tracing from just open data to using data to driving insights on data to predictive analytics to that open science model and how we can use open science to improve the city of Chicago. So thank you very much.
Thank you, Tom. Questions? Okay.
So I come from the city of Milwaukee, which is starting to do some open data things. And in the discussions that I've been a part of in Milwaukee, one of the big factors is that Milwaukee has a lot of haves and have-nots. And in my city, the people who most need the data have the least technology and the least training and the know-how to actually be able to use the data to better their lives in the way that the purpose behind this is. And I was wondering if you have done anything in Chicago, if you have those problems, to combat those problems.
Sure, we certainly have those problems. Everybody has those problems. There's a couple different ways of tackling it. Though we've not done it specifically, I've seen other cities try to leverage the power of their libraries to connect data with folks. And I say that here first, because if I'm going to say that, it's going to be here. But in seriousness, you see that because it connects people with data, allows people to help search for information. If librarians are plugged into the process, can they go and help maybe, oh, here's the data set that you want. Because one of the problems you have is just naming a data set. I mentioned earlier we have the list of public chauffeurs on the data portal. Well, what does that mean? Taxi drivers. Why do we call it public chauffeurs? Because now everybody on that list is a taxi driver. So we have this sort of bureaucratic language that we have to use because it's more accurate. But colloquially of somebody, it's like, well, I just want a list of all the taxi drivers in the city. And people can connect them better with that. We tend to try to work through nonprofits and community organizations to make those connections. We have a lot of those here in the city of Chicago, lots and lots of those. Again, at Hyde Park, where many of them exist here. And those folks often can make those final connections between individuals and people. But in addition, trying to just make websites better. The relaunch of the data portal was more focused on that, where embedded on the homepage now, let me just pull it up here. You have tutorials. Oh, I got to bring this over. You have tutorials on the homepage, so people are better connected with, okay, I'm on the data portal, what do I do? Right? No, don't make them jump out. Put the instructions right here and invite them in. So that certainly happens, but that's where we have to work with others to build better platforms and then also work with others to connect with folks.
So you've got a lot of data and a lot of people with access. How do you maintain the integrity of the data?
The data integrity question is always a good one because I always have a provocative answer. I don't care. When it comes to, for instance, data on the data portal, we actually have feeds coming from our operational systems. Oftentimes, for instance, the data that you see on the data portal is derived from a report that people use on a day-to-day basis. We leverage that. It's like, okay, if you want the list of people that we've paid, tell me the report that you create that shows that you've used internally for the people that you've paid. And we take that exact same logic and we create an automated feed that updates the data portal every single day off of that same logic. So the standard bearer is, if the data is something that we're using internally, and it's the logic that we're using internally, and it's good enough for us, it's good for the public as well. Now, of course, there's going to be mistakes. Every single data set, every single data is wrong. I'm a nihilist when it comes to this. But there's always going to be incorrections. But if we're using that data, and again, we're making decisions based off of that data, that's the criteria that I want to live up to.
So I want to follow up with, you've got this great idea for the array, and that gives you the potential to look at some data that might have different political implications.
Mm-hmm.
So how do you maintain the integrity of that? I'll go back to that question, because you may have internal actors in the city government that want things to be there and other things not to be there. So do you have any safeguards?
So with the array of, there's a couple of things there. One, I'll answer the array of things project because there's a more technocratic answer there, which is the university is controlling that. They're scientists using that, right? So they have that, and it's just feeding back. So that's kind of an out. That's not really answering your question. More systematically, again, we're plugging into those operational systems. So you think about how operational it is. If I'm saying that I fixed this pothole because I want to say I fixed this pothole and I want to close that down, then sure. But that action is going to be public. And if I go to that picture and I say, well, the pothole is still there, right? Because there's still evidence of that. And I trace back and it's like, well, the data portal says it's closed. Then that's where the opportunity for accountability is, right? You can always lie, but now there's just more transparency behind that and to be held account for that. Because a lot of times, people think that there's something misgiving there. And a lot of times it's no, because it's something that's actually very nuanced. Let me tell you an example about potholes. Some people will say, well, you closed the pothole issue, but the pothole is still there. And the city will say, well, it's actually not a pothole. And the reason why is because it technically isn't. It's a sinkhole because the water main beneath it has maybe collapsed in. That collapses in. That's not a Department of Transportation problem. They say, that's not me, that's them. And then they'll close that issue, and then they'll transfer and create a new issue over here and say, nope, that's your problem. And so now we've done a better job of communicating that. It's like, well, yeah, your request was closed and your number was satisfied, but there's a new number now that was created because now that's a new work order for somebody else. They have to you just don't patch that in because the thing's going to collapse again because everything underneath it's collapsed. And so you actually got to go in there, you got to fix the pipe, you got to get beneath the surface. It's not just shoveling a little bit of asphalt. So even things like that, it can help increase clarity and understanding of what is a very bureaucratic experience. 33,000 employees, there's a lot of bureaucracy behind that. There's a lot of work, there's a lot of work orders, and it allows us to communicate that better.
To follow up on that question, I think there is a separate issue besides, like whether a single data point in one of these open sets gets changed by somebody. I mean, I don't know if you can attach names to that or whatever, and you probably don't want to, but there's another thing, which is what kinds of data sets you decide to share and which you don't, and you referred to this in your presentation. So I was wondering if you could speak a little bit to that about what remains internal and why, and how those decisions get made, and whether the public can, know even just like a list of what those data sets are or something, because that seems to also be an important part of accountability to me.
It does. We've tried that sort of inventory. First, you got to know where all the data potentially exists, which is a massive exercise of trying to find out. That goes from spreadsheets to big systems. We know where the big systems are, but even something like that. So we've shied away from that, frankly, because we want to been focused more on opening up when something pops up. And the way that we figure out, okay, what do we want to prioritize for the data portal, tends to fall along the lines of 3 or 4 different dimensions. One is just low-hanging fruit nature of it. Like, can I get this ready and can I get this available to the public right now? And if I can, we tend to gravitate towards that because it provides immediate value. But we also have to measure that against something else, such as the value. Like, this is really low-hanging fruit, but really nobody cares about that, right? So if there is there value that's attached to a data set. 3 is, what is our chance of keeping that data up to date? One of the challenges that we have is something may not be kept up to date very well or not very systematically, so it's hard for us to establish a plug to get that to a data portal on a regular basis. One of the things we're very concerned about is stale and dated data. We can do a lot of effort, and we can do a Herculean effort of getting a data set on a data portal as of 2012, because we do a lot of work, we do a lot of survey collection, and then immediately it grows older and older and older, and it would take another Herculean effort of getting that data available onto the data portal again. So we really try to focus on things that we can deliver freshness to and update on a regular basis. And then finally, the other thing that you have to go through is you have to get buy-in from all the stakeholders to get that done. And that's the longest, hardest part of it. So sometimes we have to play a long game to get something onto a data portal. In fact, in about an hour and 15 minutes, one of the most intriguing data sets that we've ever released is going to be released on the data portal. Many people know about the strategic subject list in the city of Chicago, CPD's list of people and what the chance we think somebody's going to be involved in a crime. We're releasing an anonymized version of that list to provide transparency of who we find might be the people most likely to. This is something that's been highly, highly sought after. Many, many FOIAs have been issued beyond it. And it's taken a long time, but just in a little bit here, we're going to be able to make that transparent for the first time ever. And so now there's going to be transparency into that process, something that people have had a lot of concern about over the years. And that's a long haul. That's a long burn. That's not a this week thing. It's not a low-hanging fruit, as I indicated earlier. It's high value, but it takes some time, and it took a lot of stakeholders to get involved in that as well. So it's a complicated calculus, but it's a calculus that we have to make good on, and the way that we get held accountable is, what do you see on the data portal? What's there, and what do you think is not there that we need to make available?
As a pothole owner, sort of, a pothole that kept recurring, I have some experience with trying to get it fixed, and eventually it was fixed. But I'm wondering about errors in the system. Like, for example, I gather that a restaurant would be listed as having violations. Is that right?
Yeah.
So if the restaurant feels that there's a mistake there, does that restaurant have an adequate mechanism to complain? And does that happen quickly?
Yeah, I can't say if it happens quickly or not, because more or less every single sort of bureau and manager has a process for appeal. I think more to the restaurant's concern is, okay, you failed me, and now I have this marker on my list, and I have to pay a fine. That's probably their first line of concern of, I don't want to pay this fine because I don't think this was a justified fine. So there's an appeal process for that where they go back to the department and say, no, I don't think that this is a correct assessment. That's going to differ a lot between the different agencies and however they've kind of worked that out with their respective folks. Maybe so, but that's not something, at least on the open data side, that's not something that we want. Let me put it this way. Our objective is to reflect, what is the city doing, right? If we failed somebody, all right, then that right now is our record, and that's what we've done. Let's make that available to others so others can work with that, either on a kind of predictive data science way or just simply, where is the city failing? Who are they failing? Where is that happening at? So our objective is, on the open data front, is to reflect what the city of Chicago is doing and has done.
Okay, one final question.
I was curious, with all the data that you're collecting, if you've thought about sort of implications if these analyses will end up adversely affecting certain groups of people, and how would you account for that? Like, I think about things like racial profiling, or then when you're giving the example of looking for where crimes may be committed, I immediately think of Minority Report, which may be a little bit more in the future, but I sort of wonder, when looking at these big collections of data, if there's false causal assumptions between different things, or sort of how you might be avoiding, like, trampling on the rights of certain people or making false assumptions.
Yeah, so the explicit way is I think fairly easy, right? Of don't include factors that that would be profiling explicitly. What becomes more subtle and what becomes more difficult, and frankly this is where there's a lot of conversation on, not just for governments but also for companies and startups of like, is algorithmic transparency, or is that sort of algorithmic ethics. There's a few different words that are floating around for that. Is, okay, what if I'm implicitly biasing against a population? And part of today's release that's happening later is so people can explore that and they can know what that might be. Because now it gets very, very difficult. It gets very, very difficult to separate that out. In one part, that's what you're interested in. You're interested in the things that influence something. On the other side, though, you don't want to pursue things, though, that just reinforce negativity and inequality. And that's a very, very hard line. In one part, we hope that transparency, whether it's very algorithmic transparency, like literally publishing an algorithm or publishing the results of something, that's one step that you have to take, because it allows other people to have a conversation about this is unequal, this is a problem, whatever it might be. So we have to take that step, and then we have to do a little bit more in terms of figuring out what is the baseline ethics that everybody needs to follow. And that's not there yet. There's organizations that are really starting to come together that's trying to address that. The Civic Analytics Network that I'm a chair of, we actually have a breakout group that's trying to get together a commission, more or less, to study that issue. How do we provide transparency around that? What are the ethical ways that we use algorithms? What are the unethical ways? And then there's other organizations that were trying to do that. Just prior, with the previous presidential administration, DJ Patil, who is the chief data scientist for the United States, was working on that issue as well. That has fallen off from the federal radar at this point, but I suspect other nonprofits and philanthropies and organizations are going to start picking up that. But it's a very, very good question, because there's not a guidebook for everybody to go to for every single one of these circumstances. Like, what's a fair and equitable use of using algorithms within government like this?
All right. Thank you very much.
Thank you.